Okay, so we are in the middle of chapter 9. However, we are moving to chapter 19, section 1, because we need to deal with oxidation reduction reactions. Okay, so in your notes, it's number 5 under section 2. But notice it says chapter 19, section 1. So if you're confused about this stuff, go there to look for your answers. We're only doing section 1, too. Okay, oxidation reduction reactions. This is a reaction in which electrons are transferred from one atom to another. And it's also called a redox reaction because people don't want to say oxidation reduction every single time. So in the picture, you see an, I don't know, a molecule?
Could be.
An atom. It could be just an atom of an element. But it has this electron here, and it is going to donate its electron to the other atom or compound, whatever it might be. So then over here, it has been oxidized because it lost its electrons. This one is being reduced because it accepted an electron.
Okay.
Okay. Oxidation is the loss of electrons from atoms of a substance. So your example, you have this written in your notes, is sodium. Sodium as an element, it will have 11 electrons.
Okay.
It wants to get rid of that one valence electron, so it's going to have a positive 1 charge here. Okay, so that means that sodium has lost an electron. That's why you have an electron written here.
Okay, so we just have this free electron now that could go someplace if we added it to something else.
Yes.
Okay.
Okay, and then reduction is the gaining of electrons by atoms of a substance. So you've got chlorine here, it's diatomic, so that means you have 2 chlorines bonded together. That means that for each chlorine you need 1 electron, so that's why it says 2 electrons have been gained. And then in the end, you end up with a -1 charge for each chlorine.
Okay, so we broke it down into each thing, we broke it into its ion to show what charge it was, how many electrons it either gained or lost.
Yes.
Okay.
And then down here, this is at the top of your next page of notes, but it says loss of electrons is oxidation, gain of electrons is reduction. So remember this saying, it's kind of goofy, but everybody uses it. Leo Gurr. You can really say grr.
I know it, these.
That's how we feel about them. Okay. Now, this is showing you that oxidation reduction reactions can happen in all sorts of different types of reactions that we learned about before. So this one is showing 2, well, let's see, we've got 1 element and we've got a gas here. They are combining to form a product. So this is a synthesis reaction, but it's also a redox reaction because magnesium here is going to lose 2 electrons, because remember, magnesium has 2 valence electrons that it wants to lose. So magnesium loses the 2 to oxygen. Okay, so down here in our picture, magnesium is the one.
So it was stable. Now once we join it, we always have to look at the charges and crisscross things.
Yes.
So we can take a look at what the 2 plus comes from.
Yes.
All right.
Okay, so magnesium, let's think about Leo Gurr. Okay. It lost 2 electrons. I don't know where my mouse went, but it lost 2 electrons and it became a positive charge, so it's being oxidized. Oxygen is gaining 2 electrons, so it is being reduced. Remember, Gurr, gain of electrons is reduction.
So don't go by the reduction definition that you normally think of. Think opposite. Okay.
Okay. Now, when we say potassium is oxidized by chlorine, we know that potassium is being oxidized and that chlorine is responsible for it. So if we just say that, it's easy to tell which one is an oxidizing agent. But if you're given a chemical equation, you have to be able to figure out which one's the oxidizing agent and which one's the reducing agent. Now, this is when it gets kind of confusing because
they're using the same terms, but they add agent at the end, so it's opposite of what we just identified.
Yay. Okay, so oxidizing agents, these are substances that oxidize another by accepting the electrons. Okay, so make sure you have that as it oxidizes another by accepting the electrons. Now, reducing is the other way. So this is the substance that reduces another by losing the electrons.
Okay.
So if we look at this problem down here, you've got 2 potassium
right.
plus chlorine 2
Okay.
yields 2 KCl,
All right.
or potassium chloride. So look at potassium. Potassium wants to lose 1 electron. So
Right now it's stable,
yes,
but if we make it into its
loses
product,
an electron.
it became the +1.
Now it becomes a positive, so it was oxidized.
All right.
Okay. Chlorine, it wanted to gain electrons, so GER, gain of electrons equals
stable.
reductions.
It was stable and went to a negative charge. If you're moving from stable to a negative, you've gained electrons. Grrr.
Okay, so what's happening here with these agents that we have to identify now is we have to say, okay, which one accepted the electrons? That's your oxidizing. So chlorine accepted an electron over here, so the oxidizing agent is going to be Cl2.
Okay.
Because over here, as our reactants, potassium gave chlorine gas an electron, making this compound. Okay, now the reducing agent is the one that loses the electrons. So your potassium lost the electrons to become a positive, so now it's your reducing agent.
Okay, I think the next slide will help immensely see how much easier it is to identify the oxidizing agent and the reducing agent.
Yes, okay. Remember back in, what chapter was it, 6?
Yes.
Electronegativity.
Yes.
Okay. Elements with low electronegativity. So the metals, remember your trends, these are on your cheat sheet. You probably thought you'd never see them again. Well, here they are. Okay, your electronegativity increases as you go up and to the right. So anything down in this bottom, what corner is that? Left. Bottom left corner, which are metals, they are going to be strong reducing agents.
Because they want to lose them. They want to become the positive ion.
They want to lose those valence electrons,
yes.
like the 1s or the 2s that they have to lose. Okay. High electronegativity for your non-metals. Okay, so these guys up here in the corner. Remember that fluorine is your most electronegative non-metal. So these are going to be good oxidizing agents because they want to gain electrons. If you think about oxygen, this is where we get the term oxidizing, but oxygen really wants to gain 2 electrons, and it is right around here on your periodic table.
Okay.
Okay, so let's look back at this slide. Look at potassium.
Metal.
Potassium is a metal, so it is a good reducing agent.
Okay.
Look at chlorine. Find it on your periodic table. It is a non-metal. It's in the upper right-hand corner. It is a good oxidizing agent. Okay, so if you're having trouble identifying it the way that we did before, look at your periodic table and try to figure out where they fit.
Okay.
Okay, determining oxidation numbers. So your book in chapter 19 has like 9 rules. I've only pulled out 2 because I think that's all you need. So the first one. When you're determining the oxidation number of any element or diatomic molecule, just assume that it's 0.
Because it's stable.
So if you see hydrogen gas, H2, that's going to be 0. If you see any element by itself, like zinc, silver, magnesium, sodium, those are all going to be 0. And then any of your other diatomics. Okay. Oxidation number of atoms in a compound is equal to the charge of the ion. So if you've got NaCl, you know that sodium contributed 1 electron. It has a +1. Chlorine has a -1 charge. Magnesium chloride, okay, magnesium contributed 2 electrons, so it has a 2+, and chlorine has a -1 charge.
Okay.
So this becomes important because now you need to figure out your oxidation numbers in a redox reaction. So I've given you one here. It's already balanced. All we need to go through is figure out what is the oxidation numbers for each of them.
Okay.
And then figure out which one's being oxidized, which one's being reduced. And then I gave you a hint there at the bottom already. The other
But that's
three
okay.
things that you need to do.
It'll make more sense once we actually go through it and you see the ions changing from reactant side to the product side. I think that'll help a lot.
Okay, so first, let's look at KBr, or potassium bromide. Let's assign oxidation numbers, or charges, to each one.
Okay.
K has a +1, Br has a -1.
If you don't know these by now, we did a bad job.
Then
in
we're in
chapter
trouble.
7.
Okay, chlorine 2, it is diatomic chlorine, so it's a 0, which was your rule from last slide. KCl, you got a +1 and a -1 for chlorine. Okay, and then bromine as a diatomic.
Yep.
What's it going to be?
0.
Good. Okay, so all you're dealing with here are 1s and 0s. You might have 2s or things like that, but we're not going to be that mean with these reactions. We just want to know that you know the basics of them.
Yes.
Okay, so now let's start by looking at all these charges. If you look at potassium, potassium has a +1 on this side, but potassium also has a +1 on this side. This means that it had no change in oxidation. Okay, notice that no change in oxidation means that it is something called a spectator ion, which we will get into in the next section.
Well, briefly, we could just say a spectator is somebody who's not part of like
Right.
a game.
Mhm.
If you're watching a sporting event,
Right.
spectator just sits on the side. It's not really part of it. It's just there.
Yeah.
So potassium is just there, but not part of what we are really looking at.
Mm-hmm. Okay, so now let's look at bromine. It is a -1 here,
Okay.
and it changes into a 0, the oxidation number. So,
Lost an electron
yes, okay.
because electrons are negative. It
So,
was a -1 to a 0.
Leo, loss of electrons means oxidation.
Okay.
You can look at the charge. It goes from a negative number up to 0.
Mm-hmm.
Okay, so that means loss of electrons. Now let's look at chlorine. Chlorine goes from 0 to -1. So the charge is going down by 1, therefore it is being reduced.
Because it's gaining the electron.
Mhm.
It went from a 0 to a -1. Electrons are a negative charge. It went to a negative. We gained an electron. Grrr!
That's all they're going to remember.
Grrr!
Okay, so now we have to identify what is the oxidizing agent. Well, I've already written it for you here. It is chlorine, and I probably should say Cl2.
Okay.
But it is the oxidizing agent because if you look back in your notes, where did I put it? The oxidizing agent is the substance that oxidizes another by accepting the electrons. So chlorine here accepted an electron from bromine and became a -1 here. Reducing agent, this is the one that's going to be losing them to the other, so this would be your reducing agent, bromine. Okay, that is redox reactions. That's all we expect you to know for this class, but if you get to AP Chem, you will go into it more in depth.
Have fun with that.